Symmetry is something we kind of talk about in the paper, in particular with this kind of example of a pencil, which I happen to have here. And the way to kind of think about it is symmetry is something really useful when you are learning for kind of downstream tasks in the world. So if you're just learning, to classify a data set or something, then it's maybe not something you're that interested in. But if you want the system to then be able to take these representations as developed and do something with them, then it's really useful. And in particular, if you consider a case like this, imagine a system that's learning to write. Which way you kind of hold the pencil along kind of as you rotate like this doesn't really matter. But obviously, whether you hold the pencil like this or this does matter. And so what Monty is kind of able to do is understand, based on the shape of this object, that these representations are symmetric, and it can kind of all cluster that into kind of one thing, whereas this is not symmetric. And that means that as soon as it's learned to kind of write with the pencil in one orientation, you can spin it around and it will still be able to write. It doesn't need to kind of relearn how to do that. It sounds really simple because humans just constantly recognize symmetry and use that, but it's a surprisingly difficult thing to put into an artificial system. One of the things that's exciting is we didn't set out to develop a system that could solve symmetry or naturally recognize it. It was just something that naturally kind of fell out of having a sensory motor system with reference frames.